Okay, good morning students. So today we have lecture number 3 on electromagnetic induction. Lecture number 4 on electromagnetic induction. We have started already. Lecture number 4 on electromagnetic induction. Okay, so we are solving the numericals in the previous lecture. So let us solve some more numericals. So next numerical, write down the next numerical. I'll dictate the question. You write down the question. A square loop of side 10 centimeter. A square loop of side 10 centimeter. A square loop of side 10 centimeter and resistance of 0.70 ohm. A square loop of side 10 centimeter and resistance of 0.70 ohm is placed vertically in the east-west plane. A square loop of side 10 centimeter and resistance of 0.70 ohm is placed vertically in the east-west plane. Is placed vertically in the east-west plane. In the east-west plane. In which plane? East-west plane. Okay. Give please stop. A uniform magnetic field of 0.10 Tesla. A uniform magnetic field of 0.10 Tesla is set up across the plane. A uniform magnetic field of 0.10 Tesla is set up across the plane in the northeast direction. Is set up across the plane in the northeast direction. In the northeast direction. You please stop. In the northeast direction. You please stop. A uniform magnetic field of 0.10 Tesla is set up across the plane in the northeast direction. You please stop. The magnetic field is decreased to 0. The magnetic field is decreased to 0 in 0.70 second. The magnetic field is decreased to 0 in 0.70 second. The magnetic field is decreased to 0 in 0.70 second at a steady rate. The magnetic field is decreased to 0 in 0.70 second at a steady rate. You please stop. Determine the magnitude of induced EMF. Determine the magnitude of induced EMF. Determine the magnitude of induced EMF and current during this time interval. And current during this time interval. Determine the magnitude of induced EMF and current during this time interval. Determine the magnitude of induced EMF and current during this time interval. Okay. So this is the question. So see the question and try to understand the question properly. Okay. Once again I will read. A square loop of side 10 centimeter. Square loop of side 10 centimeter. 10 centimeter is the side. So square means all the sides are equal. Side 10 centimeter and resistance 0.70 ohm. The resistance of that coil is 0.70 ohm is placed vertically in the east-west plane. Is placed vertically in the east-west plane. In which plane? East-west plane. Vertically in the east-west plane. Okay. A uniform magnetic field of 0.10 Tesla is set up across the plane. A uniform magnetic field of 0.10 Tesla is set up across the plane in the northeast direction. So magnetic field is in the northeast direction. This is east, this is west, then this will be north and this will be south. The magnetic field is set up in the northeast direction. That means northeast direction means in between the north and east here. So this is the direction of the magnetic field. So this is uniform magnetic field. Magnetic field is set up in the northeast direction. Okay. northeast direction, the magnetic field is decreased to 0 in 0.70 second at a steady rate. Determine the magnitude of induced EMF. Okay. So from the figure, clearly, so the angle made by the normal drawn to the plane, that is, if you try normal to the plane, the normal drawn to the plane of the coil makes an angle of 45 degree with the magnetic field. Clearly, the angle made by normal to the plane of coil, the angle made by normal to the plane of coil with magnetic field, is 45 degree. The normal drawn to the plane of the coil, let us say this as east and this as west, east west, and this is north and south. Okay, I am taking only in one plane, east west north south, and the square loop is in the plane of the east west plane, it is like this or like this, square it is, square, all the sides are equal. Okay, square it is, all the sides are equal, so it is in the east west plane. Now the magnetic field is directed along northeast direction, it is in between the north and east, it is here. And now if we try normal to the plane of the coil, the normal drawn to the plane of the coil makes an angle of 45 degree. So from here to here the angle will be 45 degree. So 45 degree with the magnetic field. So that angle you have to understand from the given data. So now we want so magnetic flux. So magnetic flux is changing. So that is the magnetic flux. That is initial magnetic flux. Let us say initial magnetic flux. Final magnetic flux will be 0 because magnetic field is decreased to 0. He has told the magnetic field is decreased to 0 in a 0 steady rate. Determine the magnitude of induced EMF. So therefore initial magnetic flux. So phi is equal to this BA cos theta. BA cos theta. So phi is equal to B. Magnetic field is how much? 0.10, and area of the coil means this is 10 centimeter. So 10 centimeter means 0.10 meter, 0.10 meter, or 10 into 10 to the power minus 2. That is 10 divided by 100, 0.10 meter. So 0.10 into 0.10, length into breadth, area into cos of 45 degree, cos of 45 degree. Okay. So phi is equal to, so 0.10 means 10 to the power minus 1, this is also 10 to the power minus 1, this is also 10 to the power minus 1, 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 10 to the power minus 3, cos of 45 degrees 1 by root 2, so it is root 2, so 10 to the power minus 3 divided by root 2, so this can be done as 0.7 into 10 to the power minus 3 Weber. This is the initial magnetic flux. And now the magnitude of induced EMF, the magnitude of induced EMF is how many number of turns? Number of turns is not given. So therefore, so E is equal to magnitude of induced EMF, E is equal to, that is d phi by dt. That is the formula that we will write it as phi 2 minus phi 1 divided by t. That is phi 2 is phi 2 is that is phi 1, this is phi 1 initial, phi 2 will be 0, that is final magnetic flux. Final magnetic flux is 0. So therefore, so I'll get that is so on substitution magnitude of induced EMF will be, so that is 0.7, so 0 minus 0.7 into 10 to the power minus 3 divided by, so t, time taken is how much? 0.70, so magnitude of induced EMF, so 0.7 cancel, so you'll get 1 into 10 to the power minus 3 volt, that is 1 millivolt. So this is the magnitude of induced EMF, magnitude of induced EMF. And the magnitude of induced current. Now let us find the magnitude of induced current. So it is induced current is given by induced EMF divided by resistance. And induced current is equal to induced EMF is 1 into 10 to the power minus 3 volt and resistance is 0.70 ohm. So this can be done as I is equal to, it is 1 divided by 0.7. So into 10 to the power minus 3. So the final answer comes out to be, that is, so on simplification you will get the answer as, I'll tell directly the answer. So 1.4 millivolt, 1.4 millivolt, that is milliampere, sorry, milliampere. 1.4 into 10 to the power minus 3 ampere. So this is the answer. Okay. The answer. So understood the question? Okay. Simple questions. Just you have to think about the angle. Think about the angle. Think about the given data. So you will get the answer. So they are asking only magnitude. So minus does not matter. They are asking only magnitude of the induced EMF. So you can write it 1 millivolt. Okay. Next question. Read on the next question. A circular coil of radius 10 centimeter. A circular coil of radius 10 centimeter, comma, 500 turns. A circular coil of radius 10 centimeter, comma, 500 turns. And resistance 2 ohm. And resistance 2 ohm is placed with its plane perpendicular to the horizontal component of the Earth's magnetic field. A circular coil of radius 10 centimeter, comma, 500 turns and a resistance 2 ohm is placed with its plane perpendicular to the horizontal component of the Earth's magnetic field. Is placed with its plane perpendicular to the horizontal component of the Earth's magnetic field. You please stop. Once again I will repeat the complete sentence. A circular coil of radius 10 centimeter, comma, 500 turns and resistance 2 ohm is placed with its plane perpendicular to the horizontal component of the Earth's magnetic field. You please stop. It is rotated about its vertical diameter. It is rotated about its vertical diameter through 180 degree. It is rotated about its vertical diameter through 180 degree in 0.25 second. It is rotated about its vertical diameter through 180 degree in 0.25 second. You please stop. It is rotated about its vertical diameter through 180 degree in 0.25 second. You please stop. Estimate the magnitude of the EMF. Estimate the magnitudes of the EMF and current induced in the coil. Estimate the magnitudes of the EMF and current induced in the coil. Estimate the magnitude of the EMF and current induced in the coil. You please stop. You please stop. Horizontal component of the Earth's magnetic field at the place is. Horizontal component of the Earth's magnetic field at the place is. Horizontal component of the Earth's magnetic field at the place is 3.0 into 10 to the power minus 5 Tesla. 3.0 into 10 to the power minus 5 Tesla. 3.0 into 10 to the power minus 5 Tesla. Okay. Read the question and don't get panic as soon as you see the horizontal component A, O. So don't get panic once you see the question. Many of you people physics numerical will not solve. Lower section students especially, you people will not solve the numericals, theory numericals. because the main reason for that is as soon as you see the question you will start to get panic. So it's something is there, oh बहुत कुछ है, ये हमारा नहीं है, ऐसा कुछ भी नहीं है, बहुत सिंपल रहता है क्वेश्चन. So you have to see, read the question twice and understand the question and interpret it. You will get the answer very easily. See here, a circular coil of radius 10 centimeter. So radius of the circular coil r is equal to 10 centimeter, that is equal to 0.10 meter, and 500 turns, that is number of turns is 500, and resistance 2 ohm. Resistance, okay, I will write radius as small r and resistance is 2 ohm. This is resistance. Okay, radius I will write small r. Okay, no problem. Is placed with its plane perpendicular to the horizontal component of Earth's magnetic field. So there is a horizontal component of Earth's magnetic field and the circular coil is placed such that the plane of the coil is perpendicular to the horizontal component of Earth's magnetic field. Understood? So that is the initial angle, it is initial angle between the normal drawn to the circular coil, normal drawn to the area and the magnetic field. The normal drawn to the area, let us consider this as circular coil. This is, imagine this as circular coil and this is the magnetic field. Okay, this is the horizontal component of magnetic field and circular coil will be normal, that is perpendicular to the horizontal component of magnetic field. Okay, now if we draw a normal to this area, that normal and magnetic field both are in the same direction. So initial angle is theta 1 is equal to 0 degree. Understood? So therefore initial flux linked with coil, initial flux linked with coil is phi 1 is equal to, what is the formula? BA cos theta 1. BA cos theta 1 if there is only one turn, but there are n number of turns, so you can take n, or for initial flux linked with each coil. So for only one coil, with each coil we shall write, at the end we will take it for n number of turns. Each coil, initial flux linked with each coil. For only one coil we will consider, last we will write n. Okay, so that is B. B is magnetic field. Magnetic field is how much? Magnetic field is given. That is, what is the magnetic field given? Read the question, you will get all the things. Horizontal component of Earth's magnetic field at the place is, it is BH, at the place is 3.0 into 10 to the power minus 5 Tesla. 3.0 into 10 to the power minus 5 Tesla. So it is 3.0 into 10 to the power minus 5. And area of the coil is given by pi r square, because it is a circular coil. Area is given by pi r square, that is radius is given, you can write it pi r square into cos theta 1, cos of 0 degree, cos of 0 degree. So therefore phi 1 is equal to 3.0 into 10 to the power minus 5 into pi r value is how much? Radius 0.10 means 10 to the power minus 1, 10 to the power minus 1 whole square. 0.10 means 10 to the power minus 1. So 0.10 whole square into cos of 0 degree is 1. So therefore phi 1 is equal to, so what you will get? This is 10 to the power minus 2. It will be 10 to the power minus 2 and this is 10 to the power minus pi. So 10 to the power minus 7, 3 pi. So 3 pi into 10 to the power minus 7 Weber. Okay. Initial flux linked with each coil, each circular coil, linked with each circular coil. Okay. So next what they have given? See the question, how I am reading the question, like that I am solving the numerical. It is rotated about its vertical diameter through 180 degree. It is rotated about its vertical diameter It is rotated about its vertical diameter through 180 degree. Now it is rotated by an angle of 180 degree. So therefore, final flux, magnetic flux, final flux linked with each coil is, that is phi 2. Phi 2 is equal to BA cos theta 2. So now the angle is, so it is rotated through 180 degree. That means normal drawn. If the coil initially like this, so normal will be here. So when it is rotated through 180 degree, normal will be in opposite direction and magnetic field will be in this direction. Magnetic field will be in this direction and normal drawn to the area will be in opposite direction. So the angle theta 2 will be 180 degree. That is B. B value is how much? BH. That is 3.0 into 10 to the power minus pi into pi r square into cos of 180 degree. So cos of 180 degree. It is correct. Okay. So on simplification you will get phi 2 is equal to, so phi 2 is equal to, that is simplified cos of 180 degrees minus 1 pi r square. R value will be same once again. So the phi 2 value will also comes out to be same. It will comes out to be same, but cos of 180 degrees minus 1, so it will comes out to be minus, I think. So phi 2 is equal to, so that is minus 3 pi into 10 to the power minus 7 Weber. This will be the final magnetic flux. Why it is minus? Because cos of 180 degrees is minus 1. So pi r square is same value. So all the things, remaining things are same. So you can directly write the formula directly write the value minus 3 pi into 10 to the power minus 7 Weber. Okay. So now the induced EMF, magnitude of induced EMF is, so E is equal to N phi 2 minus phi 1 divided by T. You can write d phi by dt. D phi is nothing but change in magnetic flux. Change in magnetic flux as phi 2 minus phi 1 divided by time taken is T. So therefore, so EMF, induced EMF is equal to N. Number of turns now substitute 500 phi 2, it is minus 3 pi into 10 to the power minus 7 minus phi 1. Phi 1 is also same, 3 pi into 10 to the power minus 7 divided by time taken for this rotation. Time taken for this rotation is how much? It is given. Read the question. It is it is rotated about its vertical diameter through 180 degree in a 0.25 second. Time taken is 0.25 seconds. So therefore, this time taken will be 0.25 seconds. So therefore, magnitude of induced EMF. Do the simplification. So I will tell directly the answer. Do the calculation on your own. I will tell the answer. So E induced EMF will comes out to be, induced EMF will comes out to be 3.8 into 10 to the power minus 3 volt. 3.8 into 10 to the power minus 3 volt. So this will be the induced EMF. And now induced current in the coil. So induced current is given by I is equal to E divided by R. So I is equal to E. It is 3.8 into 10 to the power minus 3 volt divided by resistance. Resistance is 2. So we'll get I is equal to, so 3.8 divided by 2. So how much it will be? 18 and 19. So that is how much? 19. It is 1.9 into 10 to the power minus 3 ampere. So this will be the induced current and this will be the induced EMF. 3.8 millivolt. 3.8 millivolt induced EMF and induced current will be 1.9 milliampere. See the numericals. So this induced EMF and induced current in almost all the numericals comes out to be smaller or bigger value. So it is coming out to be in a milliampere or millivolt. So that means induced EMF will be of less magnitude. It will not be of magnitude, larger magnitude. It will be of smaller magnitude. Understand from the numericals. The induced EMF will not be much more larger. So provided if the speed, if the coil, size of the coil, all the magnetic field, all the things are larger, then it will comes out to be larger. But normally the induced EMF will be very, very smaller. Okay. So next question. Write on the next question. The magnetic flux through a coil perpendicular to the plane. The magnetic flux through a coil perpendicular to the plane is varying. The magnetic flux through a coil perpendicular to the plane. The magnetic flux through a coil perpendicular to the plane is varying. According to the relation. According to the relation. The magnetic flux through a coil. The magnetic flux through a coil perpendicular to the plane is varying according to the relation. According to the relation, phi is equal to 5t cube plus 4t square plus 2t minus 5. So number of questions, what is the question number? It is left to you. Okay, you only write the number. The magnetic flux through a coil perpendicular to the plane is varying. The magnetic flux through a coil perpendicular to the plane is varying according to the relation phi is equal to 5t cube plus 4t square plus 2t minus 5 Weber. Calculate the induced current through the coil. Calculate the induced current through the coil at time t is equal to 2 seconds. At time t is equal to 2 seconds. Calculate the induced current through the coil at t is equal to 2 seconds. Comma, if the resistance of the coil is 5 ohm. If the resistance of the coil is 5 ohm. See here, this question is different. Okay. See what he has given. Read the question. The magnetic flux through a coil perpendicular to the plane is varying according to the relation phi is equal to 5t cube plus 4t square plus 2t minus 5. So this is the varying magnetic flux. Varying magnetic flux, that is changing magnetic flux. That is magnetic flux as a function of time. The magnetic flux as a function of time is given. That is magnetic flux is changing with respect to time. The magnetic flux is changing with respect to time. That changes occurring according to this equation. That changes in the magnetic flux with respect to time are occurring according to this equation. Then we have to find out induced current. If at a time t is equal to 2 seconds, if the resistance of the coil is 5 ohm. Okay, see here. So simple. So we know that the induced EMF is given by induced EMF, that is magnitude of induced EMF. Magnitude of induced EMF is given by, it is E is equal to d phi by dt. It is d phi by dt. That is d by dt. That is differentiation of phi. Phi is 5t cube plus 4t square plus 2t minus 5. So now differentiate this one with respect to time t. So on differentiating you will get very easily. You know about differentiation. It comes in the mathematics. So 5t cube can be written as 5 3 is 15. 15 t square plus 4 2 is 8t plus 2 dt by dt minus 5. 5 is 0. So this is the induced EMF. That is induced EMF we obtain as a function of time. Induced EMF we obtain as a function of time. So now induced EMF at time t is equal to 2 seconds. We want time is given, no? Time how much it is given? 2 seconds. Induced EMF at time t is equal to 2 seconds you find out. Then current. So induced EMF at a time t is equal to 2 seconds. So it is E is equal to, substitute the value, t is equal to 2. It is 15, 2 square plus 8 into 2 plus 2. So induced EMF will come to 15, 2 square is 4. So 15 into 4 plus 16 plus 2. So that will come to be 60, 60 plus 18, 60 plus 18, 78, right? 60 plus 18, 78. So 78 volt induced EMF. And now current, induced current, that is I is equal to induced EMF divided by resistance, that is 78 divided by 5. So induced current will come out to be, so I is equal to, so how much it will comes to be? So that is I is equal to, so on simplification you will get it as 15.6 ampere, 15.6 ampere. I is equal to 15.6 ampere. Do the simplification, you will get the answer. Okay. So this is the solutions here. In the previous problems, so far what we have solved, there was change in the magnetic flux. There was change in the magnetic flux with respect to change in the orientation or with respect to change in the area. And here there is a change, here there is a change in the magnetic flux, but this varying magnetic flux is dependent on time interval. It is time varying magnetic flux is they have asked. So this is instantaneous induced EMF and this is induced current at that instant at 2 seconds. If you take t is equal to 2 seconds instead of 2 seconds some other value, then induced EMF will be different and current will be also different if you take at some other time. Understood the question? Okay. Next question. Write on the next question as homework. Write on the next question as homework. A 1.0 meter long metallic rod, a 1.0 meter long metallic rod, a 1.0 meter long metallic rod is rotated with an angular frequency of, a 1.0 meter long metallic rod is rotated with an angular frequency of 400 radian per second. A 1.0 meter long metallic rod is rotated with an angular frequency of 400 radian per second. About an axis, normal to the rod passing through its one end. About an axis, normal to the rod passing through its one end. About an axis, normal to the rod passing through its one end. You please stop. I will read the question once again. A 1.0 meter long metallic rod is rotated with an angular frequency of 400 radian per second about an axis normal to the rod passing through its one end. You please stop. The other end of the rod is in contact with a circular metallic ring. The other end of the rod is in contact with a circular metallic ring. The other end of the rod is in contact with a circular metallic ring. You please stop. You please stop. A constant and uniform magnetic field of 0.5 Tesla. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. a constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. Give list of. Calculate the EMF developed between the center and the ring. Calculate the EMF developed between the center and the ring. Calculate the EMF developed between the center and the ring. Calculate the EMF developed between the center and the ring. This is very simple. It is rotational EMF. Rotational EMF produced in a rod due to the rotation of the rod. That formula you will use, you get the answer directly. So I will tell the answer also. So answer for this one will comes out to be 100 volt. The answer for this one is 100 volt. The answer comes out to be 100 volt. Okay. Okay. Next question. Next last question. Read on the next question. Here only we will solve. This question we will solve here only. A rectangular wire loop of sides 8 cm and 2 cm. A rectangular wire loop of sides. A rectangular wire loop of sides 8 cm and 2 cm with a small cut 8 cm and 2 cm. With a small cut, CUT cut, with a small cut is moving out of a region of uniform magnetic field. A rectangular wire loop of sides 8 cm and 2 cm with a small cut is moving out of a region of uniform magnetic field. With a small cut is moving out of a region of a uniform magnetic field. A rectangular wire loop of sides 8 cm and 2 cm with a small cut is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla, of magnitude 0.3 Tesla, of magnitude 0.3 Tesla. Directed normal to the loop, of magnitude 0.3 Tesla, directed normal to the loop, of magnitude 0.3 Tesla, directed normal to the loop. Give list of. What is the EMF developed across the cut? What is the EMF developed across the cut? What is the EMF developed across the cut if the velocity of the loop is? What is the EMF developed across the cut if the velocity of the loop is 1 centimeter per second? What is the EMF developed across the cut if the velocity of the loop is 1 centimeter per second in a direction normal to the longer side, normal to the longer side, B shorter side, A normal longer side, B shorter side of the loop, A longer side, B shorter side of the loop, question mark, shorter side of the loop, question mark. For how long does the induced voltage last in each case? For how long does the induced voltage last in each case? For how long does the induced voltage last in each case? Okay. Read the question properly and I will try to draw the diagram so that it will become a little bit easier to imagine. Okay. A rectangular wire loop of sides 8 cm and 2 cm. One side is 8 cm, another side is 2 cm. This is 8 cm and this is 2 cm. One is longer and another one is shorter. A rectangular wire loop of sides 8 cm and 2 cm with a small cut is moving out of a region. With a small cut, okay. A small cut is there. With a small cut is moving out of a region of a uniform magnetic field of magnitude 0.3 Tesla, directed normal to the loop. So there is a magnetic field 0.3 Tesla, and this coil is moving out of this 0.3 Tesla magnetic field. Okay, here is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla directed normal to the loop. It is loop is normal to the magnetic field. The area of this coil, the surface area of this rectangular coil is perpendicular to the magnetic field. Okay, so it is moving out. What is the EMF developed across the cut if the velocity of the loop is 1 centimeter per second? If the velocity of the loop is 1 centimeter per second in a direction normal to the longer side. Normal to the longer side. This is longer side. Normal to this longer side means like this. Velocity is in this direction once. And then normal to the shorter side if the velocity is in this direction. It is if the coil crosses from here. So what will be the induced EMF? If the coil moves like this, what will be the induced EMF? Okay, let's solution. Direct I will write the solution. The induced EMF is given by, for first case, that is for longer side. For longer side. For speed, for velocity is normal to the longer side. So that is A. For longer side, the induced EMF is given by E is equal to, induced EMF E is equal to d phi by dt. So it is a change in magnetic flux, d phi by dt. So that is, this is a motional EMF. The motional EMF, the induced motional EMF is given by E is equal to BLV. E is equal to BLV. Motional EMF, it is nothing but motional EMF, and thus E is equal to B. Magnetic field is 0.3, length, that is this length we have to take. This length is crossing, that is 8. 8 means 8 into 10 to the power minus 2. 8 into 10 to the power minus 2 centimeter, or 8 divided by 100, 0.08 you can write, minus 2. And velocity is 1 centimeter per second. 1 centimeter per second, that is 1 into 10 to the power minus 2 meter per second. 1 into 10 to the power minus 2 meter per second. This is 1 into 10 to the power minus 2 meter per second. So induced EMF will come so to be how much? So 10 to the power minus 2, 10 to the power minus 2, 10 to the power minus 4, and 0.3 into 8 will be 2.4. 2.4 into 10 to the power minus 4 volt. So this will be the induced EMF. Correct? Induced EMF will come so 2.4 into 10 to the power minus 4 volt. Okay. So this is induced EMF. And also they are asked for how long, that is for how long does the induced voltage last in each case. The time interval, that is the time t is equal to distance travelled divided by velocity. Distance travelled divided by velocity. And distance travelled now it will be, so as this coil will passes the magnetic field, as the coil passes the magnetic field, the induced EMF will stops. As soon as the entire coil comes out of the magnetic field, the induced EMF will stops. So therefore, the distance travelled will be this much, not this one, because we are moving. In the first case, we are moving the longer to the normal side. That is, velocity is longer to the normal side. So therefore, distance travelled will be this one, shorter side, divided by time. That is width divided by time. You can tell width divided by velocity. So therefore, t width is how much? 2 centimeter. 2 centimeter means 2 into 10 to the power minus 2, and velocity is how much? 1 into 10 to the power minus 2. So t is equal to 2 seconds. So 2 seconds. So this induced EMF lasts for a time interval of 2 seconds. So when the coil moves normal to the longer side, this induced EMF lasts for a time interval of 2 seconds. Understood? Okay. Next, for the shorter side, we shall solve for the shorter side. So it is B. For shorter side. So when the velocity is normal to the shorter side, that is velocity is like this. Under that condition, the induced motional EMF or the motional EMF is given by E is equal to BLV, that is magnitude. So now length we have to take is, it is length, this one we have to take. This B is 0.3 into, so that is shorter side 2 centimeter, 2 into 10 to the power minus 2 into velocity is same now, so 1 into 10 to the power minus 2. So therefore E comes out to be 0.3 into 2, that is 6, so 10 to the power minus 2, so 0.6 into 10 to the power minus 4 volt, 0.6 into 10 to the power minus 4 volt. So that will be the induced EMF, right? So now the time interval, this will be the induced EMF. The time for which this induced EMF lasts, the time is given by T is equal to distance traveled. Distance traveled will be now, that will be the longer distance. Distance traveled will be longer distance divided by velocity. So because this entire coil has to cross the magnetic field, that means this entire length has to cross the magnetic field, this entire length has to cross the magnetic field. So therefore the longer distance, that is 8 centimeter, 8 into 10 to the power minus 2, velocity is 1 into 10 to the power minus 2, 10 to the power minus 2 cancel, so T is equal to 8 seconds. So this EMF, that is EMF of 0.6 into 10 to the power minus 4 volt exists for a time interval of 8 seconds. When the coil moves with velocity normal to the shorter side. When the coil moves with a velocity normal to the shorter side, the EMF induced will be 0.6 10 to the power minus 4 volt, and this induced EMF exists for a time interval of 8 seconds. If the coil moves normal to the longer side, the induced EMF will be 2.4 into 10 to the power minus 4 volt, and this induced EMF exists for a time interval of 2 seconds. Understood? So this much numericals are enough. In the next class we will cover the next concept, and after the next concept we will once again take the numericals. Okay.